force F of magnitude 230 newtons acts at the origin of a coordinate system, knowing that theta sub x, or basically alpha, is equal to 32.5 degrees, f sub y is negative 60 newtons, and f sub z, which is we don't know, but it gives us that whatever value of f sub z is, it is greater than 0. Determine the components f sub x, f sub z, and the angles theta sub y, or beta, and theta sub z, or our gamma. So the given are f, which is 230 newtons, theta sub x is 32.5 degrees, and our f sub y is equal to negative 60 degrees. 60 Newton. Also, the criterion, which is, or the direction, or like a clue, that whatever value f sub z that we can solve, it has to be greater than 0. Okay? So what are the required? Would be f sub x, f sub z, theta sub y, and theta sub z. Now for the solution, we can immediately solve for our f sub x, right? Because we are already given the alpha, or our theta sub x. So from there, we say f sub x is equal to f cosine theta sub x, which gives us 230 multiplied by the cosine of the angle 32.5 degrees. And we can input that in our calculator. This gives us, so that's 230 cosine 32.5. This gives us 193.980,032,53696 newtons. Okay, having calculated f sub x, we also have f. At the same time, we also have f sub y, right? But we don't have f sub z. Now, we also don't have the angle gamma, or the angle theta sub z, right? So what we can do here is look for other formulas that shows the relationships between the three forces, or rather the four forces, and that gives us, or that brings us to the extended Pythagorean theorem, which is our force F is equal to the square root of f sub x squared plus f sub y squared plus f sub z squared, which gives us f squared is equal to f sub x squared plus f sub y squared plus f sub z squared, right? Now from this equation, 3 are given and f sub z is the unknown, right? So we can rearrange our formula, our variables rather, so that f sub z will be the one left in the left hand side of the equation, so that we can solve for it. Now we can simplify. F sub z now is equal to the square root of f squared minus f sub x squared minus f sub y squared. So from that, we can substitute the values. So that's the square root of the quantity 230 quantity squared minus the calculated value of our f sub x, which is 193.980,032,53696 quantity squared minus negative 60 quantity squared. So from that, we can input that in our calculator. Now, just a brief recall in our algebra, that if we do square root, actually we are given possible two values. We're given two possible values, one positive and one negative, right? That is in our algebra. So we have an option whether to go for the positive value of our f sub z, or our calculated value here, or we go for the negative one. But if you can see, you can recall from this problem that the criterion would be f sub z must be greater than 0. So therefore, we have to go for the positive value, and that is positive 108.03585968076 newtons. So we have calculated now our f sub z. We can now then solve for the remaining what is being required, the remaining required for this problem, which are the angles beta or theta sub y and gamma theta sub z. So for our theta sub y, that is our cosine of our f sub y, which is negative 60, divided by f, which is 230, and this gives us so from here, from what is being written, since it has a f sub y has a negative value, which is negative 60, we can expect that the angle will be greater than 90 degrees. Okay, so the calculated value would be 105.121.665.31491 degrees. So it is indeed greater than 90 degrees, since our f sub y, the value of f sub y is less than 0 or going to the negative y side of the y-axis. For our gamma, or our theta sub z, is equal to our cosine of our calculated f sub z, that is 108.03585968076 divided by the value of our f, which is 230. So we input that in our calculator. Shift cosine gives us the function r cosine, then copy, or rather input 108.03585968076 divided by 230, which gives us 61.98380405766 degrees. Okay, so that, but make sure to box your final answer. So again, this is another type of problem for 3D.